Hi, I'm Kiran Gollu. Today, I would like to talk about fast and cheap observability. Uh, you can have the cake and then eat it too. More often than not, you have to choose between speed, cost. What if you can have both, is the purpose of the talk. And before we get started, I would like to just give a brief call out for International Women's Day. Uh, uh, Thanks to kind of like all the incredible women has kind of like who's moving things forward. So yeah. What I will talk about today, the key challenges with the current observability tools and how are we addressing them today, and the key shifts that are kind of like defining the future. And we're also going to talk about the new architectural first principle approach that is like faster and cheaper, and some of the results that were achieved, and what organizations need to do to stay ahead. A little bit about me, co-founder and CEO of like Oodle, an observability startup. Before that, like I used to run platform engineering, cloud platform engineering at like Rubrik while we were scaling to almost like $500 million in revenue. And before that, founder of an incident automation startup, backed by Y Combinator. And in the early days, I was a founding team member at like Amazon S3 and DynamoDB. For the most part of my life, I spent like a lot of my time on the building developer products, scaling them. So before we dive in, what is observability, right? The definition of observability is like what's happening inside a system by looking at its outputs. So you can look at like logs, metrics, and traces, and each of these signals serve a specific purpose. The core idea is like the observability goes beyond basic monitoring, helping engineers quickly spot issues and figure out the why behind why the issues are happening. Here is a typical observability stack. You have a data collection layer, which is happening via agent, API, and so on. And then you also have different data collection tools like OpenTelemetry, Prometheus, FluentBid, eBPF that are shipping your metrics, logs, and traces via a data pipeline to a data storage layer. And the data storage layer typically has like a hot tier and a cold tier. And if you look at like hot tier, like it's usually expensive SSD based, and you also have like a cold tier, which is like more of an archival tier that is stored in like S3 or some sort of like an object storage, Azure Blob Storage or Google Cloud Storage. And then you have a third pillar, which is like data visualization layer, which is provided by Grafana, like Elastic or Datadog or Persis and tools like that. We're going to reference all of these elements in the rest of the presentation. That's why I wanted to give a brief overview here. So legacy observability tools are broken, right? Like the key reasons why they're broken is like one, they're too slow, and two, they're too complicated, and three, they're too expensive. So what changed? So the key drivers behind this are like one, we are switching to kind of like cloud native and AI workloads. And there's an explosion of data and microservices that is making these systems extremely complicated. And it's also a big line item. If you look at the overall observability spend, it's actually a third line item in the overall engineering spend. First line item is the people cost, the second line item is the cloud infrastructure costs, and the third line item is like your observability cost, and it's growing faster than your cloud infrastructure spend. So what? So how does it impact kind of like various teams and various players by having these changes? So let's look at each of the players, right? Like the teams. How does it impact like SREs, site reliability engineering teams? Hey, you know what, like my application engineers kind of like don't care about kind of like breaking production. I'm responsible, I'm getting woken up at 2 a.m. Did any of you kind of like face that challenge? I'm sure. So this is a common problem. And by the way, like keep the session interactive. If you have any questions, feel free to kind of like raise your hand. I think we can have a conversation about that. What are some of the other things that like SRE teams have faced? It's not reliable. Like it just doesn't work. You know, scaling my open source stack, the queries are slow. Despite over provisioning, it just doesn't work. Scaling my open source stack is hard. I have to rebalance my Elastic clusters, and then still my log queries are slow. And the last one is if you're using something like commercial vendors, you have to reduce your observability to reduce your costs. Hey, you know what, like my boss asked me to kind of like reduce costs, but like my product engineers kind of like don't like me anymore because like I'm actually started to block metrics and block some logs, and they can't get to kind of like what they want. So let's look at platform engineers, right? So platform engineering teams are like, hey, there are too many dashboards, too many alerts. I can't easily figure out what my engineering teams are sending, what the different services are sending, and what we actually use. Why can't my observability system just answer my question at any cardinality? Why do I have to kind of like restrict and then do code reviews and then stop blocking some metrics and so on? Because the teams are not able to send all these things, the customer experience also sucks. So let's look at like product engineering or application engineering teams, right? So the problem with the product engineering teams is that their users or their customers are like noticing the problems before they do. And it results in kind of like bad customer experience. You know what, like PMs are constantly bugging us with questions and interruptions, product managers here. Why can't they figure it out themselves? Like if the observability tools or like these tools are like easy enough, they should be able to kind of like look at this. Hey, did the new release cause any regression? They should be able to, we just rolled out a new feature flag. Is there any challenges over there, like with the new release or like with the new set of users that we rolled out this feature to? Why can't I get answers to my questions ASAP? Whatever, like the observability system should be able to answer these questions. And I want to get in, get out as fast as possible. I don't love my observability tools. You know what, like they're designed for a purpose. My goal is to kind of like make sure that I can get back and then go back to building revenue generating features, the stuff that I like to build. If you look at like engineering leadership, right? Say, hey, you know what, like we're heading to an IPO. My CFO is asking me to kind of like reduce costs to improve my margins. These commercial tools like Datadog, like few others are like expensive, and then scaling open source tools cost too much money, too much people time, and also results in kind of like customer experience and availability challenges and outages. What should I do? How should I kind of like balance which decision I'm going to make? Why can't I scale cost effectively? Yes, I want to scale, I want to send a lot more data, but I can't scale cost effectively. We're sick of migrations. Like there are weird lock-ins. You know what, like there's a weird query language. Because of that, like we can't switch to either open source tools or we can switch between vendors. And like I personally have gone through like many such migrations, painful migrations at like Rubrik. And the last one is like, you know, no vendors today build cost attribution into the core part of the product. Why should I, as an engineering leader, like engineering team, build those features myself, or like our team should build on top of the observability tools? Why can't it be kind of like natively part of the observability stack that we currently have? If you look at product managers, using observability tools is like not intuitive at all. Like kind of, I have to constantly kind of like go back to my engineers and ask these questions. Is there any regression? How is my usage and adoption of like the features looking like? How do I measure the performance and availability of my premium customers? You know, they're constantly shouting, they're going to churn if I'm not going to take care of them. So are they happy? So these are kind of like the constant questions that are coming from all these players, and these are all kind of like real challenges. Okay, so it impacts multiple teams, we understand that. So does any of the existing tools kind of like solve this problem? Let's look at the landscape, right? Both open source and commercial tools have challenges today. If you look at like kind of like open source tools, like Prometheus, Grafana, or Elastic, commercial tools like Datadog, Dynatrace, you can name like a bunch of other observability tools as well. One, they're too slow. If you look at open source tools, they're like not reliable, and query timeouts, despite over-provisioning, and they're complicated as well, right? They're not horizontally scalable. I have to vertically scale them up, yet they're not fundamentally designed for horizontal scalability. And they break at any meaningful scale. If you look at like Prometheus, Grafana, even Elastic is known to have like a lot of operational challenges. And you need an army of engineers to kind of like manage this stack. And it's not a fun job either. All I'm doing is like managing, making sure that it's up and running. Nobody likes that. And if you look at commercial tools, the challenges are like, hey, like there are too many dashboards. Like, like, how do I train my experience and like new engineers for that? And they're not optimized for kind of like end-to-end experience as well. Each piece solves a piece of the puzzle. And I have to constantly balance my budget and visibility. It's hard to do cost attribution, something that we talked about, and they have like weird lock-ins with their own proprietary language. I can't own my data. It is sent to the vendor, and the vendor can't share the data with me. Why? And we talked about it's a third highest spend in engineering. It's like quarter of your cloud bill. It's a meaningful spend. So how are different companies kind of like trying to solve the problem today, right? If you look at the first wave of companies like Datadog, New Relic, Dynatrace, AppDynamics, they tried to solve it for the user experience. They did a pretty good job. As things were moving towards the cloud, as applications were moving towards the cloud, they created a nice user experience so that there is visibility into like what's happening inside the applications. As the data kept on growing, as there is an explosion of like data and microservices, scalability became a problem, cost control became a problem, and then the new set of tools came, Prometheus, Thanos, Cortex, and Chronosphere, and Cribble, which try to solve this problem for scale and like routing of data into different layers. And there is Mimir and Victoria metrics. These tools and companies are solving the problem, but like not cost effectively. So they try to solve the problem via tiered storage. There's a hot tier, there's a cold tier. Depending on that, like you have to juggle the data between these tiers. It does help though. I think they did solve the scale problem, but like what still remains is the cost efficiency. Let's get into that. So why the legacy architectures are like kind of like no longer enough for your cloud and AI workloads? The fundamental reason, as I was alluding to, is actually they are not architected for cost efficiency from day one. Instead, they are architected for scalability and experience, which are also important. And a lot of these stores are like row-based data stores, and they're not designed for high cardinality data. So what is a high cardinality data? Being able to kind of like drill down things by customer. If you're a security monitoring company, being able to look at things by camera and then see, hey, is there an increasing traffic for this particular camera, for this particular IoT device ID? Being able to spot problems, slice and dice by any granularity. If you're an e-commerce company, being able to look at things by a particular store or a store ID, and then if there is an order drop or not for that particular store, being able to distill down to that level of granularity is challenging with the row-based data stores because they use expensive and slow SSDs. And SSDs can be as expensive as 25 times more expensive than your object storage. And replication adds like more cost. And the fourth line item is actually always running compute adds to the costs. Like most of the time, if you're looking at in the weekend, 99% of the data is like never being queried. It doesn't make sense to run like a dedicated compute when you're not using. And they're all based on kind of like lift and shift on-prem architectures. So that those are the challenges the current legacy architectures have. So why now is it kind of like a time to rethink? Observability has become a data problem. So there's a data explosion as we discussed. And there's a separation of compute and storage phenomena started by Snowflake. And there are like lots of innovations happening in the data warehousing space. People are creating serverless databases built completely on top of object storage. And people are creating like data streaming architectures. Kafka built on S3, some new innovations like Neon, Warp Stream. And they're leveraging like very, very cost-efficient architectures, much like what DeepSeek did for like disrupting kind of like the AI workloads for OpenAI and like Claude. Cost efficiency is the name of the game. And there's a serverless wave. There are like lots and lots of innovations happening around the amount of parallelism that you can have and the reduction in the cold start latencies. So you no longer have to wait a long time, few seconds before you spin off hundreds of thousands of Lambda functions going against your object store, returning the results as quickly as possible. And the last one is like generative AI. But you know, observability data has like different properties compared to this like analytical and other systems. You mostly care about recent data, and time series data is like highly compressible. And 95% of the data, even like more like 99% of the data is like never queried. It's sitting out there. And queries need to be fast. Unlike your analytical queries, like, hey, you can run a report and then wait for like an hour and then no big deal. But like when you're troubleshooting an incident at 2 a.m., it better be fast. And they do require like complex aggregations. Yet, speed is super important. So what are the requirements of an ideal solution? What do we want here? Observability is all about speed. Being able to resolve things quickly, getting answers fast for your questions. That's the purpose of observability, so that you can get in, get out as fast as possible. And it should be architected for cost efficiency from day one. It should not be kind of like something that's bolted on later. And no lock-ins. It should be simple. Migration should be simple. Customers should have like a lot of flexibility around what tools that they're using. And the lock-ins or like the selection of the tool should be based on the value that the tools offer, not based on the query language or the data locality, and being able to kind of like share the data with the customers or not. So here's a new opinionated approach. It's a new first principle approach, much like how Snowflake went after kind of like disrupting observability, disrupting data warehousing. Likewise, there is a unique opportunity with the new innovations in serverless and the separation of storage and compute in the observability land to deliver like much faster and much cheaper observability. It's an and, not an or. So we did some experiments, like we came up with like a new time series database exploiting these properties. So let's take a look at a brief look at this architecture, right? So the bold hypothesis here is that these new set of problems require a fundamentally new cloud-native architecture. If you look at this entire architecture, everything is stored in your object storage environment, and then you have like Lambda functions and no disks at all. And by having this unique architecture, you could pass on significant amount of cost savings back to the customers. The customers can store 10x more data and derive a lot more insights by slicing and dicing on high cardinality data with whatever granularity that you want. Being able to drill down by user ID, by customer ID, by device ID, by container ID. Things like that are like not possible with the current systems. So what does this mean? What does this change from the previous typical observability stack that we have seen? There's a hot tier, there's a cold tier. There's nothing like that. Everything gets collapsed into the object storage. You can build a speed layer on top of like object storage that just answers your queries fast using serverless queries. And there are no disks at all. So what are some of the results looking like with this architecture, right? Any questions so far? Okay, let's keep going. It creates an opportunity to kind of like create like a dashboard-less debugging system with the AI native interface. You can just query whatever question that you have, and it results in kind of like much faster debugging. And you can say no to static dashboards. You can create dashboards on the fly, and you can slice and dice on any piece of data, on any cardinality. And it results in 10x lower compute costs. And how are you able to kind of like achieve this like 10x lower cost with this new architecture? Because it's serverless. You only pay when you're using the dashboards, when you're running queries. It uses kind of like intelligent caching so that like the results are fast for like commonly accessed things like dashboards and alerts. And you can use like, you can avoid indexing completely, thus give the results like a lot faster. And the storage costs are also like a lot cheaper. It's like 24x like lower storage costs than storing them on cloud disks like EBS and things like that. If you were to use like a three-way replicated expensive SSDs. This is a cost per gigabyte. You're looking at around like 50 cents per gigabyte. S3 is like kind of like 24 times cheaper. And you can also leverage kind of like direct link technologies and availability zone affinity. Like you can leverage availability zone aware architectures to make sure that your networking costs are fixed and minimal. So there are no replication costs, and you can have like affinity towards kind of like your availability zones so that your egress costs are minimal. So let's pause here. So what do organizations need to do to stay ahead? Reevaluate your existing observability investments. Are you using current tools providing fast and actionable insights? Can they scale cost effectively as your systems become complex? Leverage AI for faster troubleshooting, especially for things like summarization of your incident resolution, summarized log insights, summarized anomaly insights, being able to kind of like use natural language to query and tune your alerts. Prioritize cost efficiency and scalability. Your observability systems should be able to give you sublinear pricing models so that like if your business were to grow by 2x, it should be, your cost should go in a sublinear fashion. Now the new architectures support that sort of like cost efficiency. Adopt modern cloud-native architectures. And finally, demand simplicity from your observability systems or vendors. It should be an enabler, not an operational burden for you. It should support kind of like easy deployment and easy migration. I want to briefly summarize what I spoke about today. We spoke about like the key challenges with observability today: cost and speed of debugging. Getting both is hard, but the modern cloud-native architectures that we have seen make it possible. We've also seen why the legacy architectures won't work for cloud-native and AI workloads with the explosion of data and microservices. We talked about a new opinionated view of building a new time series database from ground up that can give like 5 times faster debugging experience when troubleshooting alerts, and it's also order of magnitude cost efficient. And we also talked briefly about like what organizations need to do to kind of like to stay ahead of the game in terms of like adopting modern cloud native architectures. A simple, it's a plug here. This is the only plug that I'll talk about. In case if you want to explore, all of this is kind of like live at play.oodle.ai. Thank you.
Questions? Anybody? Sure, go ahead.
I'll just screen.
Okay, fine.
Okay, so how much of this are you actually saving and where for each piece? That is it seems like a bit of work for all of us to do in order to actually get observability that we get from new relevant.
Would you mind speaking with them?
Maybe I do need
Yeah,
it.
the rest of the audience can.
So that's a lot of work, it seems, for us who are on either New Relic or Datadog or whatever we're at, in order to build out each of these lambdas, set up the, it looks like caching engine, a database, all these other pieces that are part of infrastructure, because we still spend money on a database. Like I spend, $10,000 a month just on my own DBs. So, it all adds up. So storage might be a little bit of cost, but it seems like there's a lot more to it than that. Maybe you can explain where true cost savings is, and not just on S3, because there's a lot of more infrastructure that I see there.
Yeah. So you're right. So that's also reason why I think we built this system from like ground up, so that like we can offer that capability to kind of like our customers. But the core idea is that let's talk about like kind of like what is it that gives us this unique capability, right? If you look at this entire architecture, there are no disks for the most part. It's mostly storage in the S3 buckets. And if you were to build this whole thing from ground up, I'm not sure kind of like if I would go recommend that. It's possible. What we're trying to allude to is actually, it's possible. You can get enterprise grade observability at open source cost, which is a current challenge today. And if you look at like the cost savings are coming from querying layer in the Lambda functions here. All the querying happens on the Lambda functions on demand, and storage happens in the S3 buckets, which is like 24x lower costs. And the data is like, we do not have any Kafka clusters. So that's also like a big piece of like costs in like these legacy observability tools. And everything happens on demand. There's no indexing here, if you see this. So we built a custom storage format on top of S3, which gives you these like queries like a lot faster. But like long story short, you should be kind of like building on your observability. You should not be investing in your own observability, building this whole system from ground up. Instead, use modern architectures or like any vendors that support this like modern architecture that can give you kind of like your Datadog, Splunk at 1/10 of a cost. And so that way you can manage your data like a lot more cost effectively. So does that answer your question?
Somewhat does, but there's no way I'm going to get 1/10 of a cost. It's like, I spend what's the number now? Something like, about $10,000 a month on my Datadog bill.
Yeah.
No, on my New Relic bill a month. So you're saying I can go down to like $1,000, maybe $2,000 bill by going to one of the vendors over there.
Yes, that's correct. I think we offer that. Like I think it's public pricing, and then you can actually see it live in the play.oodle.ai as well. So if you don't feel comfortable, I think we in that play.oodle.ai you see that where here is the workload that would cost this much dollars, and then you can actually play with it without creating an account.
Oh, great. And all of these support OTel?
Yes.
Okay, I'll go check them out.
Yeah, that was a great talk. And I don't even have a question, but for the audience, I'm the founder of Icosic AI. We let you search through all of your server logs using natural language to get insights immediately in seconds rather than the hours you usually spend in your terminal. So if anyone's interested, catch me here. I'm here for about 10 minutes. Thank you.
Thank you. Any other questions? All right. Thank you very much.
Thank you very much. Yes.